The upper half of an inclined plane with an inclination phi is perfectly smooth, while the lower half is rough. What it is saying is, there is an inclined plane. Let us assume this is the inclined plane, right? And its total height is h, and this is, let us suppose, h by 2. This is this height. This is h by 2, and this is also h by 2, right? So the upper half is smooth. This is smooth. This is phi, and this part is rough, right? A body starting from rest at the top, if it is at rest, and it will move down, right? It will come again to the rest at the bottom if the coefficient of friction for the lower half is given by. First of all, let us assume this path is ABC, right? So AB is smooth and BC is rough, right? And let us assume the coefficient of friction over here is mu, right? So for AB part, what is happening? It is going down a height h by 2, which means that if I write mg into h by 2, this is the loss in potential energy, that will be equal to the gain in kinetic energy, half mv square. So from here we can calculate the value of v. V will be equal to under root of g into h, right? Now this is basically the velocity that it has gained at B, right? For BC, u is under root of gh, because whatever was the final velocity for AB will be the initial velocity for this BC, and the final velocity that we have to see is 0, right? Because over here this point should become 0, right? Now if I see the acceleration in this part, if this part, in this part, it will be g sine theta, and above we will be having mu g cos theta, right? Because of the friction, right? Let us assume that the net acceleration is upwards, right? So that means mu g cos theta minus g sine theta, right? Now here what we do is we take the axis as x is over here and y is here. So basically x is positive. If it is moving downwards, this direction is positive, right? If this angle is phi, how much distance will I have to move if I draw this triangle? So basically this is h by 2. If this is phi, so how much distance does it BC has? So BC will be equal to, BC will be equal to, this will be equal to h upon 2 sine phi, right? Because sine phi over here will be equal to h by 2 upon BC, and BC will be equal to h by 2 upon sine phi. Is that right? So this is the distance which I have to move. That means x or s will be equal to h by 2 sine phi, right? And acceleration is this, which is in the upward direction, which is basically retardation. So if I see the proper, if I use the proper dimension, so this will be negative, right? Because it is upwards, right? Why is it upwards? Why is this value greater than this? Because this particle has to stop. That means there should be a retardation, right? Now if I use the formula equation of motion, v square equal to u square plus 2as, if I put these values, v will be equal to 0, u was equals to root of 2gh, root of gh, so that means gh minus 2s is h upon 2 sine phi. I can take gs common, right? So it will be mu cos phi minus sine phi, right? H and G will cancel out. So that means what will I get? I will get, and 2 will cancel out over here and here. So I'll get mu cos phi minus sine phi will be equal to sine phi. Is that right? So that means I'll get mu will be equal to 2 tan phi, right? So basically this is the answer. So that means option D is correct.